Okay, for number 2, we're going to be doing the same thing. We're just trying to find the most helpful trig substitution we could make for the following integral. So we have the integral of dx over 1 plus 4x squared. And you might be thinking this just looks like an arctangent, and you would probably do it that way. But you could also do this one by trig substitutions. This is a good problem to show you how you do this if you had to do trig substitution. So you can see that what we have here is 1 plus 4x squared. So we need a trig identity that will have a 1 plus a trig function squared in it. And that identity is going to be 1 plus tan squared equals secant squared. You can see here that if this were to be tan squared, then we would just be able to replace the entire denominator with secant squared and go from there. So we just need to figure out how do we do that exactly, because we have 4x squared. So you can think about it either one of a couple of different ways. X is going to have to be something tangent theta, but what's that coefficient need to be? One way you can think about it is I need to square something so that when I multiply it by 4, I just get back to 1, because I don't want any coefficient in front of there. So to multiply by 4 and get 1, you need to have 1/4. And if you're squaring something and you need to get 1/4, it needs to be 1/2. The other way you can think about it is that I need 4x squared to be tangent squared theta for this to make sense, for this to look like this identity. So to solve this, I could just take the square root of both sides there. You can see these two are saying the same thing, and this is just the constants rearranged. But the answer on the sheet has it as 2x equals tangent theta. So that's how we could do this type of integral if we were going to use trig substitution.